In this tutorial, we will be using a software called Tableau Public to analyze and visualize tabular data. Our purpose here will be to show you how you can leverage the free version of Tableau, Tableau Public, to connect, transform, and explore open or primary tabular data about your library in order to detect patterns, relationships, and generate interactive dashboards for presentations and showcasing your findings to a target audience. We will do this in 4 steps: connecting source data, data pre-processing and transformation through data joins, analyzing and visualizing your data, and finally creating interactive dashboards and stories. For our exercise, we will be using 3 data sets. 2 of those data sets will be comma-separated value files. The third file will be a shapefile that I have downloaded from the City of Toronto Open Data Repository. A shapefile is a geographic vector data format for geographic information software that can be used to describe points, lines, and polygons to represent political map features like borders and physical map features like rivers and lakes. Our files will be the following: Toronto Public Library branches, longitude and latitude data, as well as year column for historical branch openings. The second file will be Toronto circulation by cardholder type, and the third will be a Toronto neighborhoods shapefile that will allow us to use the mapping feature of Tableau with 3 classifications: emerging neighborhoods, neighborhood improvement area, and not NIA or emerging neighborhood. Something to keep in mind before connecting your data to Tableau is to make sure that your data is formatted properly and is as complete as possible. This means that your cells don't have any missing values. For tabular data, it's recommended that each row is labeled properly, as Tableau will recognize column labels and assign a data type to the values. In order to leverage the information from all 3 files in order to create a meaningful visualization, we need to create data joins. Data joins form an integral part of data manipulation and integration, as they allow us to structurally combine data sets in order to manipulate and analyze them together. There are 2 types of data joins in Tableau. These include data relationships and logical data joins. Data relationships are a dynamic and flexible way to combine data from multiple tables for analysis. Data joins, on the other hand, are a more static way of combining data, as they are defined before analysis and can be changed without impacting all sheets using the same data source. When you open Tableau Public, you should see the following window. On the left-hand side, you have the different file types that you can connect, like including a Microsoft Excel file, text file that includes the CSV file that we spoke about, JSON, which stands for JavaScript Object Notation, which is a popular file representation on the web, PDF file, spatial file, which includes our shape file as well as statistical files. Next, I'm going to click on text file, where we can upload a CSV file format. I'm going to locate where my file is, and it's called TPL branch openings by year. I'm going to click open, and immediately we will see that Tableau will upload on the bottom pane here our rows and columns. Next, I'm going to click on this add button, and I'm going to add our second comma-separated value file over here. Okay, and it will be populated under connections. And thirdly, we will add our spatial file as well. So I'm going to click on spatial file and locate where my shape file is, and I'm going to choose the s.shb file. Next, we're going to do a logical join. In order to do that, I need to double click on this rectangular representation of my first data set, and as you can see, it says it's made of 1 table. I'm going to select the connection, Toronto Public Library circulation, and I'm going to select the file here. There are 2 files, I'll just select one, and I'm going to drag and drop it into this pane. Tableau will immediately interpret the connection, which is an intersection. Since both of these files that contain one table have a column with the same number of rows in common. So if I click here, it's chosen an inner join. As you can see, it's identified that they have a shared branch name column label. And the equals here just stands for quality of columns. Next, I'm going to locate the neighborhoods shapefile. To locate the file, do the same thing, drag and drop it. Select create join calculation, and I'm going to use a function called makePoint function here to convert our latitude and longitude columns into point representations on the future map that we will be making. So just a note about Tableau functions. So they work kind of like coding functions, where you have the name of the function, open parentheses, and that's where you enter the parameters. Our parameters here are in brackets because the latitude values and the longitude values are represented as arrays. I'm going to click OK. Before you do that, make sure that it recognizes that the calculation is valid. Next, I'm going to choose a corresponding field in the neighborhoods shapefile, and that will be the geometry field that Tableau has interpreted from our data set. Now, instead of equals, in this case, we will use a relationship called intersects. Okay, and you use that for spatial files, or rather shape files in general. Okay, so now you can see that at the bottom, Tableau has populated our table. Now, instead of an inner join, we're going to choose a full outer join, just because in reality, these two files have no rows in common. Okay, so in order for it to populate both of these tables into a giant table, we need a full outer join that indiscriminately takes rows from both tables. And to make this consistent, I need to convert the first join that we did also into a full outer join, so that there is no inconsistency. And since these two tables have identical matching rows and a column in common, this will not affect our join. Here's a quick overview of how the Tableau worksheet is organized. In the middle here, you have the canvas where your visualization will go. Above that, you have the rows and columns that will display the variables that you're representing in your visualization. To the left of that, you have three panes: pages, filters, and marks. Marks stand for graphical elements that you'll leverage or use into your visualization. In the filters pane, you can drop variables that you want to filter out of your visualization. Meanwhile, on the pages pane, you can drop variables that you'd like to convert into a discrete set of sequences. To the very left, you have the Data tab. The Data tab will list all of your tables and all the fields underneath those tables. The Data tab will divide your fields into fields that have categorical values and fields that have numerical values, as you can see. So we're staying on the Data tab. The first thing that I'm going to do is go to the neighborhoods shapefile and locate the geometry field, and I'm going to drag and drop that into our canvas. And what Tableau will do is it will automatically interpret the shapefile into an internal map projection. Next, we will leverage the latitude and longitude fields of the Toronto Public Libraries to create point representations of the branches. In order to do that, we will do the same drag and drop, but we will create a new marks layer. We will convert the field into a dimension instead of a measure, and then we will do the same thing with the longitude. And as you can see, this will represent each of the 100 Toronto Public Library branches as points. Next, we will leverage the classifications that we had for the neighborhoods as emerging and needs improvement into a color coding of our map. For that, I'm going to use the class 9 field, and I'm going to take that field and drag and drop it into the geometry pane that represents our neighborhood borders. So I'm going to drop it onto the color mark, and immediately it will interpret those classes by color coding our map. So the red stands for Neighborhoods Improvement Area. If we want to change our color, what we would do is we click on Color, Edit Colors, and we select a color palette of our liking. So in this case, I'll choose Lighting Color Safe. Click on the category and assign it the color of your preference. Click OK, and it should update the map with your preferred color. Next, we're going to leverage the Toronto Public Library circulation data in order to represent that on the map. So I'm going to locate the Toronto TPL circulation by card holder, and on the latitude layer, I'm going to take the teen field and drop it onto the size marker. Click on size and just increase it so that it's more visible. And in order to make this a little bit more aesthetically pleasing, I'm going to locate the branch name field, drop it onto the color mark, say add all members, and it will color code each of the branches since every branch is unique and different. To make those circular marks stand out a little bit, I'm going to click on color and add a border. The size now represents the teen population, and as you can see here, if I hover over a particular branch, it will give me the branch name as well as the teen population. Next, I'm going to leverage the date field that represents the opening dates of each of the Toronto Public Libraries, and I'm going to create an animation that displays the evolution of the Toronto Public Library system across time. So I'm going to take the date field and drag and drop it into the Pages pane, and at the bottom right of the legends, we have a little extra pane here that's been added that allows us to manipulate the pages that have been created. So I'm going to drag this timeline to the very beginning, make sure that Show History is ticked, click on Show History, make sure that Faded is ticked as well, make sure that I have it on the highest speed, but you can choose any of the 3 speeds available to you, and then I'm going to click Play. And what this will show you is an animation of the expansion of the Toronto Public Library system geographically as well as in time, which is a pretty neat feature. Another neat thing that I could do is take the classification of the neighborhoods and drag and drop it into the Filters pane. Here I can untick Not an NIA or Emerging Neighborhood, click OK, and what we'll have is an updated map of all the branches that fall under neighborhoods that are either emerging or neighborhoods that need improvement. I've gone ahead and created an equivalent map that instead of displaying the teen circulation distribution, it shows the adult under 25 distribution. Finally, I've also created a set of side-by-side bar charts that shows the distribution of adults under 25, child, and teen across the classification. Next, I'm going to show you how you can take all these visualizations and aggregate them inside a dashboard. Click on the New Dashboard button at the very bottom there, and on the right-hand side, you can see the sheets that are displayed. And what we can do is just simply double-click on our available sheets. Where it says size, I'm going to select the range for automatic. Finally, I'm going to show you how you can add some actions that will dynamically filter these maps. Click on Dashboard Actions. You will get a window, and click on Add Action. In our case, we're going to add a highlight. This will pop a new window. As our source sheet, we're going to select the circ distribution visualization, and as our target sheet, we're going to select teen circ and under 25 circ. We're going to run the action on select, as well as classify it by the neighborhood classification. So now if we click on one of the panes here, what it will do is highlight the relevant classification into the map. Next, we're going to add another action under Dashboard. And this time we're going to add a filter. Click on Filter. The source sheet will be the same, as well as the target sheets. However, we will run the action on hover, and instead we will filter by the percentage of teens total, the max range we selected. It will update our map according to the neighborhood distribution as well as the teen distribution underneath those neighborhoods. So this is a dynamic way of representing the relationships between the neighborhoods and the Toronto Public Library circulation data.